back, students. It's Mrs. Brunk again, and we are going to be continuing our look at triangle congruence, and we're going to kind of build on what we learned in the first lesson, which was just exploring triangle congruence. And remember, in that lesson, we basically, in order to show that two triangles were congruent, we just systematically went through the triangles and showed that all 6 pairs of parts, the 3 pairs of sides and the 3 pairs of angles that corresponded to each other, were in fact the same measures. Okay, and so we were kind of just checking off a list of 6 things to be able to say the triangles are congruent. And I mentioned that at some point we would show that you wouldn't really need to show all that there is some minimum requirements, some shortcuts that we could meet and still be guaranteed that the triangles would have to be congruent. And in today's lesson, we're going to learn the first of those shortcuts, called the ASA triangle congruence theorem. So then our learning goal is you will be able to prove 2 triangles are congruent using the angle, side, angle, or ASA theorem. So when I said ASA, yeah, that's what I meant. I meant angle, then side, then angle theorem. And what that really means is we just have to show that 3 parts now in the 2 triangles, not all 6, just 3 parts are congruent. But they have to be, to use this theorem, they have to be specifically 2 angles and the side that is between them. So there was a reason why they positioned them like this, A, then S, then A. It has to be 2 angles in each triangle, and then the side that's between those 2 angles that you know. And if you meet that criteria, then that's enough to say the triangles are congruent. So the ASA triangle congruence theorem says if 2 angles, so 2 angles and the included side of one triangle, so then that included means, again, the side that's between them, are congruent to 2 angles and the included side of another, so the same thing, you have to know the 2 angles and the included side of another triangle, then the triangles are congruent. So what we mean when we say, again, this angle, side, angle, it would be like, so say we have the side, right, in a triangle, and then we know this angle, and we know this angle, right? So these sides will continue like that, right? But if I knew this angle was congruent to an angle in another triangle, I knew this angle was congruent to another angle in this other triangle, and then I knew that the side between those 2 angles. So that's what we mean by angle, side, angle. So when I have 2 triangles like this, so say we knew that these 2 sides were the same length right here, right? So let's say that side and that side were congruent, and then excuse me, then I knew that that angle and that angle were congruent on those 2 triangles, and then I knew that, say, these 2 angles were congruent, then again, that would be the angle, side, angle, and that would be enough. So the reason why that works is this. So if you've got that side that we've marked equal, and we create angles off the ends of that side, okay, you know, those angles have sides on them, and the other sides as well, right? So those sides, once they create that angle, and they continue off on their path, they're eventually going to cross, like right up here, right? And so there's really no other way for that triangle to be formed once we determine the 2 angles on either end of that side. So in effect, those 3 parts are enough to determine what that triangle is going to look like. And so if they're the same, it will absolutely determine another triangle that looks just the exact same size and shape. So let's see if we can apply the angle, side, angle congruence theorem to some triangles. So it says determine whether the triangles are congruent and explain your reasoning. Now, basically, we're not necessarily, and sometimes be able to tell if triangles are actually congruent with this or not. We might just be able to say we don't have enough information if we can't, determine, say, all 6 parts or these specific 3 parts. But remember, if they don't have the same angle measures in them at some point anywhere in the triangles, then we know, A, they're not congruent on a whole. So this first pair in A, we've got, let's see, I've got an angle right here that's 45 degrees. And then in the other one, I don't have a 45-degree angle. but I do have enough information to figure out what this missing angle is. So step one is I'm going to use some arithmetic to find out what's the missing angle. So I took 74 and 61 away from 180 degrees, and I found out that that angle is 45 degrees. That's what was left over, is 45. So I've got a pair of congruent angles there, right? Okay, let's see. Actually, let me fix that. There you go, because we know that that angle is 45. So then we have this pair that is angles that are both 61. So we got that. And then see the sides that are between those two markings are on a side that is 2.3 centimeters. So those are the same length. So we've been able to establish, see they have two pair of angles and a side between them that are congruent. So they are congruent by the ASA theorem, and I can say something like this. Triangle ABC is congruent to, so if I called this one, I go like this around ABC, like that, then I'll have to go DEF. And the reason why it's by the ASA. And I've shown that with my markings. And so when it says explain your reasoning, that's basically my explanation, is to mark the drawing and show that I've met the requirements to use this theorem. So let's take a look in B and see if we can establish some things that we know for sure are congruent. So we know that in angle, or the first triangle and the second triangle, we both have two angles that are the same. We know they're both 31. We can tell right there. We also know that they have this side that's 62 inches long in both. Okay. So I have an angle in the top triangle that's 110. And I have an angle in the bottom one that's 38 degrees. Now, those are not the corresponding angles anyway. They're not the matching ones. If I wanted to use this 110 degree angle, I would have to know angle P. Now, if instead I wanted to use the 38 degree angle in the bottom triangle, I would have to know K. But then look, that would be, if I knew that one, let's say I found this one was 38 and then this one was 38. Look at those markings. Those markings are not showing angle, angle, side. Those are actually showing, I'm sorry, they're not showing angle, side, angle. They're showing angle, angle, side. And that's not one that we know is a theorem. So it might be, but that's not one we know yet. And so what we want to do is actually see if we can figure out what angle P is, because then, see this angle right here, okay, and then if we knew angle P, let's say, that would be establishing two angles and the side between them. So, got to do a little work first. Got to see what that angle P is. So we're going to take that, the two angles that we know, and we're going to subtract them from 180. So we can subtract 31 and we can subtract 38 and see what remains. And when I did that, I actually got 111 degrees. So hey, guess what? That means, those are not congruent. They're really close, but we have not been able to establish, these in fact are not congruent. And then that is because we can tell that angle P is not equal to angle L. So right away, we have enough to say they're not congruent. Now, sometimes you can't find enough information, but you can't for sure disprove that they're congruent, or can't say they're not, they're not congruent. In this case, we absolutely know they're not. And the reason why, and our support would be, hey, look, see these angles? One's 110 and one's 111. So they're just simply not the same measure. These triangles are not congruent. Okay, let's take a look at example C. So example C, notice one thing that really kind of stood out for me with this one was I noticed there was no measurements listed on it at all, which if you look at those other ones, they had all kinds of measurements, angles and sides listed and whatever. But, so I have to kind of look for clues then. And I do see that one pair of sides and one pair of angles is marked congruent, right? And then I see that this one has a little right angle symbol on it. But if that angle on the right is a right angle, then the angle on the other side also has to be a right angle. And the reason why that is they together form a linear pair, right? And so since they're a linear pair, they have to add up to 180, and if one angle is 90, the other has to be 90. And so we know that those both have to be right angles, so they're congruent. And so you can see we've established angle, side, angle again in both triangles. So one of them just happens to be the right angle. So we didn't really need to know specific measurements because of the markings and because of what we know about linear pairs and that angle being a 90-degree angle. So in example D, I see that there are some measurements again, and I see that there's a side here that's marked 1 inch and a side that's here that's marked 1 inch. So I know that those sides are congruent. That's a start. There's not a rule about what you have to start with. I just thought, well, I saw those, so I'm going to mark those. I see there's a 38-degree angle here, and there's a 38-degree angle here. Okay? So then I've got a 72-degree angle listed in the first triangle, and then a 67-degree angle listed in the other. Now that 67-degree angle is not in the same position or the corresponding angle to the one that's 72. That actually, though, if you look at what I've got, angle, then side here, I would need to know this angle right here was congruent to this angle right here in order to prove they're congruent, because then I'd have angle, side, angle. That's, as far as I know right now, that's the only shortcut I know. And so the one I really want to target in on is I want to figure out what angle R is right there so that I can see if it's 67. I could find out what angle S is, and it might be 72 as well, but that's not going to help me right now because I'm trying to establish a certain order of parts. And so the missing angle here at R is going to be 180 degrees minus 72 and minus 38, and I got 70 degrees. So right there, glad I did not assume anything, because now I know, nope, these are not congruent. So the triangles are not congruent because angle R does not equal or is not congruent to angle U. One is 70 and the other is 67. They're certainly close. And when these look so much alike, they're going to be close, but they have to be exact to be congruent. So that's another pair of triangles that are not congruent. Now, these next examples, they ask a little bit different question. This time they say, what additional information do you need to prove the triangles are congruent using ASA? So if we wanted to establish these were congruent using the angle, side, angle, what additional piece of information would we need? Well, you can see in the first pair, we've got two pair of angles marked congruent. We have this angle and this angle, right? We have these angles at Y and K. So we need a side, but which side? Okay, because there's three sides in the triangle, right? Could it just be any side? Well, specifically to use angle, side, angle, it has to be the side between the two angles, right? So to show that these were congruent, I would have to establish that side XY, so you'd need that XY was congruent to LK. Now notice when I wrote that, I wrote starting at X and going towards Y. So I started at the angle with a single arc on it. So I have to do LK over here. Okay? So that's what I would need to be able to prove ASA. Now in this next one, I have a pair of sides marked congruent, right? And I have a pair of angles marked congruent. So I need another angle because I'm using angle, side, angle, right? But I specifically need the angle on the other side of the side we know. So it can't be like W and F, okay? It's actually got to be the one that's on the other side that also touches that side that we know is congruent. So it'd have to be this one and this one right here, right? So then we would have that side being, you know, it's kind of sandwiched in or bookend in between those two angles, okay? So it's like the angles are kind of holding the side in. So we'd have to know that angle X, we would need to know that angle X was congruent to angle G. That's additional information we would need. Okay, so now we're going to look at some proofs. Okay, so we've done a little bit of proof writing, and we know that basically they're just some real detailed explanations where we have to state some properties that support some facts that we might be claiming. And so we've got these two pieces of given information. So remember, we always establish like the given. And they tell us that angle MQP, so I'm going to locate that one. MQP, it's this one right there. And they're saying that that angle is congruent to NPQ. So NPQ is over here. Okay? So what I'm going to do is mark those congruent because they told me they are. I'm not going to question it. That's their, if they give it to me, it's established as a fact. And they actually stated that right here on my first line. So we say that's given. So check. Now the next one they told me was MPQ. So MPQ, this one right here, was congruent to NQP, this one right here. So I've marked that. That's also written in the proof. That's given. Sometimes you'll see them write both on the same line, and sometimes you'll see them separate things that are given. But what you always want to do is make sure you take the given information and display it on the drawing so that you have a visual, like a counting of that. Oh, I know these facts already right off the bat. So in the proof, the next line says this. QP is congruent to QP. So they're saying that this side right here is congruent to this side right here. It's the same side, right? They're saying that thing's congruent to itself. Now, remember back when we learned like reflexive, symmetric, transitive properties? The reflexive property was the one that said something is congruent to itself. So this is actually the reflexive property of congruence. I usually will shorten that up and just write reflexive or just reflex. But you can also say of congruence. So maybe I'll shorten it up to say reflex congruence. Reflexive property of congruence. So I don't have to write the whole thing. So now if you look at our triangles, we got an angle here, a side here, and an angle here. And we have the same thing down here. Actually, it started with this angle, and then this side, and then this angle. So it just looks like the triangle was rotated around, right? If you can kind of imagine starting with the point M here and rotating it around like that, it's just going to turn the figure around. So that's actually the transformation that would map that figure out the other as some sort of rotation. And so we've established that the triangles are congruent, and the reason why is the angle, side, angle congruence theorem. So that's not so bad, right? It's really just kind of going through establishing what information they already provided and then seeing if we can tell, giving some of the theorems that we've learned and looking at the drawing, other things that we can establish so that we get those three parts that we need, two angles and the included side. Okay, so let's take a look at another one. So this time they give me again, two pieces of information, but the first one is that angle A is congruent to angle C. So again, you're always wanting to mark your drawings. So like if you're doing online assignments with this, it's a good idea just to sketch the drawing and actually mark them. So I'd always encourage you, whether you're doing paper and pencil proofs or you're doing them online, get a sketch of that drawing because the markings are so essential to your understanding. So make sure you're marking them. Then they go on to say that E is the midpoint of AC. So if you look at AC, like they're saying that point E is in the middle. Well, what that means, we know that that's, well, first of all, that's given, and this is given, right? And so it tells us that E is the midpoint. So if that point's the midpoint right there, that means these segments on either side are equal. We know that. And that's actually what's said in the next step in our proof, right? So it says that AE is congruent to CE, and we know that that's because of the definition of midpoint. When we learned the definition of midpoint, it said it's the point that divides a segment into equal parts. So we'd say definition of midpoint, and now we're up to 2 parts. Remember, we need 3. So that next line says that angle AEB. So let's see, AEB, that's this angle right there. And then this angle right here, they say those are congruent. Well, think about what kind of angles those are. If you can kind of imagine, let's see, these segments kind of extending out like this, like that, right? Those are vertical angles, right? So we're applying the vertical angles theorem within these triangles because these angles are formed by those two segments that intersect, and then they go on to create triangles, but those are vertical angles, right? So we could say these are congruent by vertical angle theorem. So if you were writing this theorem or this proof all on your own, you would have to look at the figure and say, okay, what things look congruent? Well, of course, they're all the matching parts are going to look congruent, but then which things can I prove? And there's only certain things you can tell by just looking at a drawing, and vertical angles are always equal. So that's one of the things you can always tell. And you can also tell that, like, say, two angles that make a straight line are a linear pair, so they have to add up to 180. You know, there's just only certain things you can tell just by looking at a drawing, and that's one of them. Vertical angles are always equal. Now you can see we've gotten all the things that we need. We've got 3 pairs of parts marked. We have an angle, a side, and an angle, right? So we have angle, side, angle. Congruence theorem is how we know the triangles are congruent. Okay, so we're going to do one more proof together, and we're going to leave the final proof as a you try, and what I'm going to ask you to do with that is to submit that to me in a certain way. So when we get there, I'll let you know what that is. So these, notice, are completely blank. There's nothing given to us. So now we have to try to come up with all this stuff on our own. Well, we know that there's always some certain, like, aspects, or and when you think about the anatomy of a proof, there's always certain things that are in certain spots, like the given information is listed first. So notice there's 2 pieces of given information. We could write those right on our first lines for our statement. So we could say angle JLM is congruent to angle KML, and angle JML is congruent to KLM. Okay, so those are the 2 angles that are listed up here. And again, this is given information. So we got 2 freebies right there, right? So we also know that the very last line, and we don't know if this is going to have 4 steps or not. A lot of times they'll give you a table like this. It's blank, and it may have more lines than you need, may have less, or let's say you had combined those 2 given information pieces on the same line. Maybe you have one left over, one more line in your table left over. They're really just kind of like a general table. Sometimes you need more lines, sometimes you need less. So I assigned these 2 for separate lines, so I've got 2 of my spots. Whatever the last line is, though, I know that this will be what is listed there, because once I can say that, I'm actually done, and I've done what I was trying to prove once I give a reason. So I got to mark this stuff. So I'm going to go up here and mark, and what they're trying, and also I'm going to highlight these triangles, because this is a little bit confusing drawing. But they're wanting me to prove that JML, so see, JML, that's this big triangle here. This is another really good strategy, is using color. And then they want me to KLM, so this one. So they're wanting me to prove those 2 big triangles that overlap. See how they're overlapping right there? So now I'm going to mark the information that they've given me. So let's see, JLM. So JLM is this angle right here in the corner in that yellow triangle. And KML, which is this angle right here in the green triangle. So if you can kind of imagine, like, pulling them apart, sometimes you'll see people will do this. They'll just redraw them separate. If that is a strategy that helps and you relabel them, then feel free to do that. So like they might have said like this, and then on the other one they would say this is LMK, and then what we just proved is that angle right there is congruent to that angle right there, okay? So if that helps you, that's a great strategy. And then JML, so JML is actually over here. It's that little angle in the yellow triangle, and it's congruent to KLM, which is this little angle in the green triangle. And in our little separate drawings that we pulled out, it would be meaning like those angles right there. So see, definitely having those triangles separate makes it a little easier. But the reason why they're together, and what we get, the benefit we get from them being together and overlapping like that, is you can see they share an entire side, right? They share that side right there. That's LM is in the one triangle and ML is in the other triangle. So they share that in common. So I could say that LM, that segment, is congruent to itself. Now sometimes you'll see, and if I want to be technically correct, I would maybe call the other one LM, because one's LM and one's ML, because one's going to the left and one's going to the right, so we usually switch the coordinates around, but regardless, it's the same segment. And that means that's the reflexive property of congruence, right? It's a shared side, so if it's the same side, of course it's congruent to itself, right? So now we're up to those, and so then our separate little drawings, if you did that, it would look like this. And so now we've established the two angles and the included side, right? So we got that side in the middle on these, and we have the two angles, okay? So that's angle, side, angle again. So we know, we know that these are congruent by angle, side, angle. So triangle JML is congruent to triangle KLM by angle, side, angle. Okay, so I'm going to help you a little bit on this one. I'm going to help you get started, and then I'm going to ask you to give an effort to finish this. And then when you've finished it, I want you to go to Google Classroom to the assignment that you'll see. And on that, you're just going to take a quick snapshot of this and upload your response. Okay, we're going to give you some points for that. So again, you just find the assignment that goes to 5.2, and there'll be a place where you can click upload your work, and you're just going to take a quick picture of that and send it over to me, okay? If you have any problems with that at all, feel free to reach out to me. But it's a pretty easy process, especially if maybe you have like a phone or an iPod or something like that that you can put the app on. But if there's, for some reason, that doesn't work out, you just let me know and we'll figure out something else. Like maybe you could show it to me in class the next day on camera or something like that. But the easiest thing to do is to upload it to Google Classroom. But again, I'm going to get you started on it. So there's two pieces of given information, and we're trying to prove these triangles are congruent. So this is a little simpler drawing. So step one is I'm going to write the given, and they're saying that S and U are right angles. Okay, that's given. So they're saying this is a right angle and this is a right angle. So I'm marking it on the drawing. They're also telling me that RV bisects SU. So it's saying that this segment right here is the bisector of SU. Okay, so that's the bisector. So sometimes I'll write on here bisects SU. That's also given. So the tricky thing about this is now they haven't really technically given us any parts are congruent, right? So we're going to get you started. And I'll get you a couple, and then you have to finish the proof and submit your work. So the first thing I know that's true is that those two angles that they said were right angles, they have to be congruent. And I know it seems obvious that they already told us that they're right angles, but we really need to say that they're congruent because we have to have a statement in our proof somewhere that says those angles are congruent. Okay, we can't just assume that our reader knows, oh, they're right angles, they must be congruent. We have to say it. So they are, and it's because of the right angle congruence theorem. Now that's a theorem we've learned. It should be in your packet. You also could say definition of right angles, or you could even just give a little explanation and say something like they're both 90 degrees. Okay, so it doesn't always have to be a formal name of a theorem or property. It could be you actually sort of in your own words stating the property, like they're both 90 degrees because they're right angles. That would be fine. That would be an absolutely fine reason. So we've marked those. So actually technically now if we wanted to like change the markings on this, we could like actually change this to say they're congruent. Okay? So then they told us that RV is the bisector of SU. So that means it must be passing through the midpoint. In other words, that T must be the midpoint. And so I know that this segment right here and this segment right here have to be equal. Okay, I can say that ST is congruent to UT. Now that means that I have to give a reason for that. And when I think in my mind how I knew that, well, I know that bisect means to cut into two equal parts. So I could say its definition of bisector But then I know that because that's the bisector, it goes through the midpoint. So I could say definition of midpoint. So we have some options here. You could say definition of bisector or definition of midpoint. Okay, so I've got you to two parts, right? We have angle and side, angle and side in these two triangles. And we just need one more thing. So this is where I'm going to end, and these are for you to finish. So you're going to finish the proof, right? Oops, let me do that in a little brighter color. You're going to finish this for your you try and finish for you try question, and then submit on Google Classroom. So when you finish this, finish it right now. As soon as you're done with the lesson, actually won't be done with the lesson until you finish this. Take a quick snapshot of this question and upload it to Google Classroom. And thanks for coming to class. I'll see you soon.